The primary value of logic is that it allows us to convert one statement into two or more logically equivalent statements. So if we want to find the truth value of a statement, it suffices to prove the truth value of any logically equivalent statement. Now, a key assumption in logic is known as the law of the excluded middle. A statement is either true or false. Actually, that's badly worded since it's a disjunction, and so both could be true. A better phrasing, if a statement is not true, then it's false, and inversely, if a statement is true, then it is not false. So what this means is that if we want to find the truth value of a statement, we can find the truth value of the statement, find the truth value of any equivalent statement, find the truth value of the negation, or find the truth value of any equivalent negation. So what's the negation of a quantified statement? Let's find the negation of the statement, no quasits are glurby. So first let's consider the statement, no quasits are glurby. Now, no quasits is a universal statement, so we'll use a universal quantifier for things in the set of quasits. And so if Q is the set of quasits and G is the set of glurbies, then this statement can begin for anything that's a quasit. Now, we know that no quasits are glurby, and that means that if something is in Q, if it's a quasit, it can't be in G. So for anything that's in Q, it is not the case that it's in G. Now, remember, we can shift the negation across the quantifier by changing the quantifier. And so an equivalent statement is, and so the negation is going to be, and so in plain language, the negation is there is some quasit that is a glurby. Or let's find the negation of some fleurons are glurby. Since the statement deals with some fleurons, we'll use an existential quantifier. So if F is a set of fleurons and G is a set of glurbies, our statement can be expressed as there is something that is a fleuron, and that thing is also a glurby. So that's in G. So the negation will be, and we'll shift that negation into past the quantifier, switching it to a for any, and negating the following statement. And so we can express this. This is saying that for anything that is a fleuron, it is not the case that it's a glurby. So any fleuron is not a glurby. Or let's consider another negation. For some glurbies, there is a quasit that is stromulus. Now, since order matters, we are quantifying a statement about glurbies and quasit. Since the statement is about some glurbies, we'll start with an existential quantifier. So if G is our set of glurbies, Q is a set of quasits, and S is the set of stromulus things, then there is some glurby. So for some glurby. And since the statement indicates that a quasit exists, we use an existential quantifier for the quasits as well. So there is some quasit, which is stromulus. Y is in S. And we'll negate it. We'll shift that negation across the quantifiers and switch them to the other type of quantifier, which gives us, and we can rewrite this not Y in S as saying that Y is not an element of S. And we can read this as for all glurbies and for all quasits, they are not stromulus. Or again, equivalently, for all glurbies, no quasit is stromulus. Or, suppose we want to write the negation, every fleuron has a glurby that is quasit. So every fleuron suggests a universal quantifier for things that are fleurons. So if F is a set of fleurons, G is a set of glurbies, and Q is a set of quasits, our statement can be written starting with for anything that's a fleuron. Now, while every fluorine has a glurby, we don't know if that every glurby corresponds to a fluorine. So there's some glurby, and so we use an existential quantifier. And then finally, for this glurby, we know that it's quasit, so Y is in Q. And so our negation is going to be, and we'll shift that negation across the quantifier, switching it to an there exist. We'll shift it again, switching it to a for any. And we can read our final statement. There is some fluorine for which any glurby is not quasit, or we could also rephrase that there's some fluorine for which no glurby is quasit. Or let's consider one more negation. For every glurby, there is a quasit for which all Rockroys are stromulus. So let G be the set of glurbies, Q the set of quasits, R the set of Rockroys, and S the set of stromulus things. So remember that order matters. So we're talking about, in order, glurbies, quasits, Rockroys, and stromulus things. The statement is true for every glurby and all Rockroys, so the element of G and R should be assigned a universal quantifier. But since there exists a quasit, this is assigned an existential quantifier. And so, for all glurbies, there's some quasit, which, for all Rockroy, that is stromulus. And the negation will be, and shifting our negation across the quantifiers gives us, and that final negation of Z in S is also Z not in S. And we can read this as, there is this, some glurby, which for any quasit, there is a Rockroy that is not stromulus.